this. Now, Mike Boll should be credited for this idea, which is brilliant. So for over 4 years, I've been looking at this, and this is one of the most brilliant ideas I've heard of that cannot be debunked, as you're going to see, which absolutely blows away NASA's model.
Hey, let's have a closer look at this brilliant idea and see if it can be debunked.
The problem with this is that in the helical model, the sun is 400 times farther away than the moon is. So if our stellarium guy could only see the top of the sun rising because the horizon was blocking the bottom of it, how can he then turn around and also see the top of the moon when the angle to the moon is so much steeper due to it being 400 times closer to him? And yes, I realize that this diagram isn't to the scale the ball earth is made up out of thin air, but surely you must realize that if the hypotenuse of one right triangle is 400 times longer than the other, these acute angles are going to be very different.
Okay, this is the only time I'm going to interrupt this program. I'm going to repeat this little teeny short segment again because this is the point you need to get. Mathematically, there's no way around this. Pay attention. You're going to see this once again, this little short segment.
So if our stellarium guy could only see the top of the sun rising because the horizon was blocking the bottom of it, how can he then turn around and also see the top of the moon when the angle to the moon is so much steeper due to it being 400 times closer to him? And yes, I realize that this diagram isn't to the scale the ball earth is made up out of thin air, but surely you must realize that if the hypotenuse of one right triangle is 400 times longer than the other, these acute angles are going to be very different. This problem becomes easier to visualize when the moon is at peak new. Again, from Cornell College Astronomy Department. At new, the moon rises at sunrise and sets at sunset. Of course, that's got to be the case in the helical model, right? Because if our stellarium guy can see half of the sun here and turn around and also see half of the moon here at the same time, then he's got to be able to see half of the sun and half of the moon at the same time here. Because the only thing that has changed is that the moon is now on the sun side of the Earth. The distance from Mr. Stellarium to the moon hasn't changed at all, which means his angle to the moon hasn't changed either. And of course, his angle to the sun is identical to what it was before, right? So does the new moon alignment make it easier to see the problem? How can Mr. Stellarium see the new moon rise with the sun if the two objects are at very different angles?
Here I've just loaded a sunrise from LA, February 14th, 2018. Sun and moon, atmosphere on, same thing. Again, with the atmosphere off. And we'll compare this. We'll model it first, then compare it to their model. Okay, on the left will be the time and date example. And on the right, we'll see how it looks in stellarium, starry night, etc. Now, Mr. Boll and Mr. Thrive and Survive think somehow we look down through the Earth and we can see the moon and the sun, and that the sun should rise first. Okay, we'll head over to timeanddate.com. We'll load one of the cities that Mike Boll uses in his examples. It's Pontiac, Malaysia, 5:45 a.m. May 5th, 2019, and we're at a new moon phase. Now we simply have to come over and place the cursor over top view, and we see that is actually a North Pole view. It's not a top view directly over Pontiac, Malaysia. Pontiac on this model would be at the very top center of the globe. And from this information, we now know where the sun is. The sun is in direct line with this arrow, but we still have the moon below the line of sight. But this is because of the polar view. Now we can load this into another program, Celestia, and we'll see the difference between a polar view and a top view over Pontiac. Okay, what I've done here is I've loaded Celestia. I've set the date for May 5th, 2019, 22:45, which is 6:45 a.m. local time for Pontiac, Malaysia, one of the cities they use in their videos. Here I'm just going to add a horizontal grid to the simulation. And here I'll put the latitude and longitude for Pontiac, Malaysia. So now we have a direct view, top view, right over Pontiac, Malaysia. Here I'm going to add 3 reference markers, sun direction, planetary grid, and the terminator line. And what I'm going to do next is to split this screen vertically. And on the right hand side here, I'll load the view that timeanddate.com uses, and that's a polar view. Okay, so what we have here now is what the observer sees from Pontiac on the left hand side here. And on the right hand side we have a simulation of what timeanddate.com does. That is a polar view. In this example we have the sun pointing east on the right hand side, so Pontiac, Malaysia would be at the very bottom of the globe here. Okay, so on the timeanddate.com example here, what I'll do is I'll collapse everything into a point so you can see where the sun and moon come in. I collapse it. You should see the moon come in first here. It comes in around the 75-degree mark. If I collapse more, the sun should come in around that 90-degree mark. There it is. Expand back out. And the moon around the 75-degree mark. And the sun direction arrow will also be around the 90-degree mark. Now if I select here on the left the view from a person in Pontiac, Malaysia, and what he would see, we'll start collapsing it and see what we find out. We have the sun direction around the 75-degree mark here. Keep collapsing, and the moon should appear, there it is, also at the 75-degree mark, and collapse more. The sun also at the 75-degree mark. So everything is in a straight line. Expand back out. The moon is on a 75-degree mark. It can be below or above the ecliptic, and if it's on the ecliptic we would have an eclipse. And expand back out and we see the person here in Pontiac sees everything in a straight line. The direction to the sun, the moon, and the sun. Everything in a straight line as it should be. Now, I have no idea why Mr.Thrive and Mike Boll are doing experiments that show a view that's from the North Pole. I mean, what is that going to prove? It's going to prove that the moon does come in on a different angle. The sun direction for a person down here in Malaysia is still at 90 degrees. Anybody on the terminator line here is going to see everything in a straight line. From a polar view, from the time and date example, the moon will never be lined up with the sun. So if we go back and look at the model that Mr. Thrive and Mike Boll use in their experiment, we now know Mr. Stellarium just looks due east to see the sunrise. He does not look down to see the sunrise. That's bullshit. He does not look down to see the moon. That's bullshit. And we know he doesn't look down to see the sun, so that's bullshit. So what we have is Mr. Stellarium just looking at the horizon at sunrise to see the sun. And the thing is, it only takes 2 seconds to debunk this silliness just by hovering over the top view, and you'll see it is a North Pole view.
Now, Mike Boll should be credited for this idea, which is brilliant. So for over 4 years, I've been looking at this, and this is one of the most brilliant ideas I've heard of that cannot be debunked, as you're going to see, which absolutely blows away NASA's model.
Well, certainly I disagree with Mr. Thrive and Survive as this being one of the most brilliant ideas ever. Only takes 2 seconds to debunk. The only thing that Mr. Thrive and Survive and Mike Boll can do, playing with string out in 100-degree weather, is to prove that the Sun, Moon, and Earth will never line up from a polar view from Earth. From this experiment, it's impossible to demonstrate the view that an observer would have from a location on Earth. Well, thanks for watching, and I guess we'll wait for the next brilliant idea.